Hello friends, in our last session we had completed our reducing properties of the aldehyde and the ketone laboratory, that is the laboratory test of aldehyde and the ketone. Today we will start with the uh, chemical reactions of aldehyde and ketone. There are total the 8 chemical reactions are there, and plus other things have given, that is the oxidation and the reduction reactions of the aldehyde and the ketone is there. So first chemical reaction we will start afterwards. First we will start with the oxidation and the reduction reactions of the aldehyde and the ketone. So let us start with the first one, oxidation. Oxidation of aldehyde and ketone. Now in this first oxidation, it means obviously the which oxidant, which oxidizing agent we have to use. Then very commonly, I told before you also that KMnO4, K2Cr2O7, HNO3, etc. are used as dilute HNO3 are used as the oxidizing agent. So which oxidize the aldehyde? Which oxidize aldehyde to the acid is there. Suppose if we take one of this KMnO4, it is known as potassium permanganate. K2Cr2O7 is known as potassium dichromate, and HNO3 it is known as a nitric acid. Due to the presence of this oxidant, oxidizing agent which supplies the oxygen, so this aldehyde, it means C double bond OH, CHO group, it changes to COOH group, that means the acidic group is there. Suppose if we take one of the example, acetaldehyde, CH3COH. Now this acetaldehyde, when it is oxidized in presence of acidified potassium dichromate, then potassium dichromate formula is K2Cr2O7 in dilute H2SO4. Then what will happen? This K2Cr2O7, it gives the oxygen to this aldehyde. So we get this extra oxygen, it is supplied from the oxidant, oxidizing agent is there. So in this way, acetaldehyde, it changes to acetic acid is there. So this question can be asked in the exam. What happens when acidified potassium dichromate, it is react with the acetaldehyde? Either how will you prepare acetic acid from the acetaldehyde? Then first of all, you have to write both the formulas. Suppose if they ask how will you prepare the acetic acid, then you have to write first acetic acid formula CH3COH. From the acetaldehyde, then you have to write the acetaldehyde formula. And then you have to compare both reactant as well as the product. Then if you see on the product side, one oxygen is extra. That means always you have to just click in your mind that oxygen is extra, it means it is the oxidation reaction. And in the oxidation reaction, we have to use the oxidizing agents. And as I told you before, oxidizing agents we have to use, normally in this case we are using the acidified potassium dichromate, means K2Cr2O7 in dilute H2SO4. In the last session we had done that in the case of the aldehyde, this hydrogen, it is directly attached to the carbonyl carbon. So this aldehyde, it is easily oxidized to the acid. But in case of the ketone, hydrogen is not directly attached to the carbonyl carbon. So, but Oxidation is possible in the ketone also, but due to this presence it is not possible. There is the less carbon atom we are getting. But if, for example, if we take one of the ketonic example, CH3, C double bond O, CH3. If suppose acetone if I write, and then in presence of chromic oxide, this is also one of the example. It is used in the case of the ketone only because it is the strong oxidizing agent. In case of the ketone, hydrogen is not directly attached to the carbonyl carbon, hence we have to use the CrO3 as a catalyst is there. Now due to the CrO3, this acetone is directly converted into the acid CH3COOH, acetic acid. So you have to remember this. It's a two molecules we are getting, two molecules of acetic acid we are getting. So we have to balance this reaction. But suppose they can ask dash we get after the oxidation of the acetone in presence of CrO3. Then we get acetic acid by the oxidation of acetone in presence of CrO3 is there. Suppose if we take one more example for the ketone. Suppose if we take the ethyl-methyl ketone, suppose. Then what is the formula of ethyl-methyl ketone? CH3COC2H5. Suppose this example if we take. Then the another name, IUPAC name is what? Then it is the, suppose numbering it starts from nearest to carbonyl carbon. So it's 1, 2, 3 and 4. Second carbon, that is the C double bond O present. So it is butane 2 on is there. So this 2-butanone or butane 2-on, this is the ketone. So no K2Cr2O7. We have to use CrO3 as a catalyst. Now in this case we are getting the two different types of acid we are getting. One it is CH3COOH means acetic acid we are getting, and other we are getting the propionic acid. It means one it is CH3COOH plus C2H5COOH. So we are getting the mixture of acetic acid and the propionic acid is there. If there is the oxidation of the ethyl-methyl ketone, then there is this C2H5COOH, it is nothing but the propionic acid. This is acetic acid. Acetic acid, another IUPAC name. There are the two carbon atoms are there. We can say it is also known as the ethanoic acid is there. So remember one thing, butane 2 on, it gives the ethanoic acid plus propanoic acid is there. So this is the about the first one, oxidation of aldehyde and the ketone is there. Now the second one, we will start with the reduction. Second is reduction of aldehyde and the ketone. It is again divided into the two types are there. The first type is Clemson. Clemson reduction and the Wolff-Kishner. Wolff-Kishner reduction is there. Now in this Clemson and the Wolff-Kishner reaction, first we will see the differentiation between these two. Aim is same. In both the reduction, we want to prepare only the alkane is there from the aldehyde and the ketone. Suppose if we take aldehyde and reduction, it means, as I say earlier, reduction it means what? Addition of the hydrogen. and in the addition of the hydrogen, aldehyde and the ketone, it gets converted into the alkane. So it is known as a Clemson reduction is there. But Wolff-Kishner reduction, in that case, we are not adding the hydrogen, but we are adding the hydrazine. It is two-step reaction. So first let us see one by one. Suppose if Clemson reduction, then in the Clemson reduction, it is only first of all one-step reaction. It is only the one-step reaction. Catalyst is used is zinc amalgam. Zinc amalgam, it is known as ZnHg in concentrated HCl. This catalyst we have to write on the arrow, and this carbonyl carbon means C double bond O, carbonyl carbon, it gets converted into the methylene group is there to form alkane. So let us see one by one. Clemson reduction, it means it is only the one step reaction. Catalyst we are using in this, it is a ZnHg in concentrated HCl, and carbonyl carbon, it gets reduced to methylene groups to form the alkane is there. It is about the Clemson reduction is there. Suppose if we take one of the example, if I take the, suppose the acetaldehyde, then acetaldehyde CH3 COH plus hydrogen, because it is the reduction is there. On the arrow, as I say, it is the ZnHg concentrated HCl on the arrow. Now, what do we get now? This carbonyl carbon changes to CH2 first of all. Then this CH3, this CH2 and this hydrogen, it is added in that. So to form ethane first. CH3, CH3, it means it is C2H6 ethane we are getting. Plus, what do we get? Now, how much hydrogen we are adding? What about this oxygen? This oxygen, it is combined with the hydrogen to form water molecule H2O. Now, we have to balance this reaction. Now, just count the product side hydrogen. 3N, 3, 6, 7, 8 hydrogens on the product side. On this side, now reactant side, 3N plus 4. CH3, 3 and 4 hydrogen. So, how much hydrogen we have to add? Then the 4 lessened hydrogen we have to add to balance this reaction. So, see this, from the acetaldehyde, we are getting the ethane by removal of the water molecules. Suppose if I take another example. Suppose if I take the acetone, CH3, CO, CH3, which undergo reduction, 4 hydrogen, same catalyst we have to use. Then this C double bond O always changes to CH2. So we have to write CH3, CH2 and CH3. It is nothing but it is known as propane plus H2O. So from the acetone we are getting the propane by removal of the water molecules. This is about the Clemson reduction. Now Wolff-Kishner. Let us see now Wolff-Kishner. In this case, heating sign we have to write on this reaction. Now in the Wolff-Kishner, what are the rules first? It's a 2 steps are there. 2 steps reactions are there. In this case, the catalyst we are using is the NH2. It is known as hydrazine. It is known as hydrazine in step 1. In step 1. In the step number 2, there is the addition of KOH and this we are adding KOH as well as the ethylene glycol. This OH, CH2, CH2, OH, it is known as the ethylene glycol is there. Then to form the alkane. So both the reaction motto is to form the higher alkane is there. Now let us see the first one of the example. Suppose if I take the example is suppose C2H5 COH, or either we can write in this way also, in this case CH double bond O. When this propanol, it is react with, this is the step number 1, react with NH2, then what do we get first? Hydrazine first, then this H2 combined with the oxygen to removal of the water molecule. Whatever left, we have to join that first. So it is C2H5 CH double bond N single bond NH2. It is known as the hydrazone. This is hydrazine, azine. It is ozone. Hydrazone. Now in the step number 2. This step number 2, in this case, in presence of, as I said earlier, in the step number 2 we have to use KOH plus OH CH2 CH2 OH, heating sign is there. Now see what is the reaction in this case. This two nitrogen combine, nitrogen gas is given out. Now what is left? This double bond will remove. C2H5 combine with CH and this H2. We have to combine both this to form CH3. So it is C2H5 combined with the CH3 to form what? It is nothing but the C3H8. It is known as the propane is there. So in this way, this is the Wolff-Kishner reduction is there. So once again I repeat, this Clemson reduction, Wolff-Kishner differences, this is the one-step reaction, it's a two-step reaction. In this Clemson reduction, we have to add the hydrogen and catalyst is zinc amalgam in concentrated HCl is there, and carbonyl group, it is changes to methylene group to form the alkene is there. In case of Wolff-Kishner, it is two steps. Second thing, hydrazine. Hydrazine formula is NH2-NH2 we have to add in the step number 1. Then NH2 it undergo the condensation reaction. Condensation, it means a removal of the water molecule. So in the case of the aldehyde, C double bond O is there. So C double bond O, that oxygen combined with the hydrazine, two hydrogen. So there is a removal of the water molecule to form the hydrazone. That hydrazone, again it is heated with KOH and ethylene glycol to form the alkane by the removal of the nitrogen gases there. So this way, this is the Clemson and the Wolff-Kishner reduction is there. One more reaction I would like to tell you that. Suppose Now suppose if we take the second example of for the Wolff-Kishner, ethyl phenyl ketone. What will happen if ethyl phenyl ketone undergo reduction by the Wolff-Kishner method? Then first of all, we have to try to draw the structure of ethyl phenyl ketone. Now this phenyl group is there. Then the benzene ring we have to write. Benzene ring is there. We can write in this way also. Now this benzene ring, there is the ketonic group. They mentioned it's ketonic group. So it's a C double bond O. Then the ethyl group. So ethyl group, it is connect with this carbon. It's a C2H5. Then this ethyl phenyl ketone, as according to this Wolff-Kishner's rule, it is react with the hydrazine NH2. Then what do we get? This oxygen combined with this two hydrogen to form water molecule, and which is changes to see, I have written same thing. It's a C2H5. Now this double bond, it will remain as it is, this double bond, NH. So this hydrazine, it is converted to the hydrazone is there. When this hydrazone, when it is heated, so step number 2, when it is heated in presence of KOH and OH, ethylene glycol, CH2OH, it is known as ethylene glycol. Remember this thing, ethylene glycol. When it is heated, then there is the removal of the nitrogen. So this 2 nitrogen, it gets given out as liberate as the nitrogen gas. Whatever left, we have to just join that. So what do we get? That's first C2H5. Now after nitrogen, how many hydrogens are remaining? 2 hydrogen. This 2 hydrogen we have to write here. So it is known as what? It is known as, it's N-propyl. Benzene is there. Why propyl is there? Because the 3 carbon atoms are there in the straight chain. Because see this, in this way, this straight chain. So it is N-propyl. It is the benzene ring is attached. So it is the N-propyl benzene is there. So Wolff-Kishner reduction is used to synthesize straight chain alkyl substituted benzene. Is not possible by Friedel-Crafts alkylation reaction. Whatever I am just telling you now, it is used in MCQ. This method, it is used to prepare the straight chain alkyl benzene. This reaction is not possible by the Friedel-Crafts reaction. Thank you.
आपको वीडियो